let's talk about 312 stuff. And I haven't been looking at the viewer count because it always upsets me, but I glanced at it today. 33. We're not doing so well at 10:20 in the morning. So let's take a look at homework 2 again and kind of give a summary of where we're at in this homework. After today, you're going to have everything that you need. What's up, Napseps? You're going to have everything that you need to complete this homework. Today is going to be the objective 4. You already have what you need to do objectives 1, 2, and 3. So today is all objective 4. But let's give a quick roadmap of where we're at. Objective 1, you're hosting HTML, CSS, and JavaScript. If you do the bonus objective, you're hosting your own HTML, CSS, and JavaScript. If you're not doing the bonus objective, you can take that sample site that I gave you and host those files. The important thing here is getting the right MIME type in the content type and specifying that MIME type. Oh, I already said it. Specifying that MIME type in the content type, and then setting the no sniff option to tell the browser that you got the MIME type correct. We'll look at this in grading. Obviously, I'm in the testing procedures here. We're going to look for this and make sure you have the no sniff. So just because the page renders in the browser through your server, if you don't have this no sniff and the correct MIME type, you're still going to get some points off. That would probably be a 2 at that point. If you're missing these things. So make sure you get those in there and get those, start thinking about your MIME types. The next is UTF-8 string. We spent like a lecture and a half. All of Monday was talking about this. UTF-8, some UTF-8 characters, most UTF-8 characters, as it turns out, are more than 1 byte long. They have more than 1 byte of a representation. So making sure that you get the right content length is the objective 2. That's what objective 2 is all about, is getting your content length correct. Your content length must be correct, and it can't be hard-coded. This UTF-8, you're only sending UTF-8.txt. You could figure out the length. You could just guess and check your way to the proper length, the number of bytes. We're going to make sure that you don't have that hard-coded, that you're actually reading the number of bytes from that UTF-8 string. How detailed does the bonus front end have to be? Not too detailed. I'm not looking for anything crazy. If you technically meet the requirements in the document, you're going to be fine. If you give a really sparse page, like if you give something with about equal detail of the sample page that I gave you, I won't be thrilled about it, but I'm still going to give you the points. But if you're technically missing something, like if you don't have an external CSS file, if your CSS is inline, that'll be a 2 on that, things like that. Did I specify that it has to be? Yeah, I did, because it has to be 3 separate files. So if you do like inline CSS, for example, I'm going to take points off. The TAs will take points off. But it doesn't have to be too detailed. As long as you have the 3 files and you made it your own, you personalized the thing a bit. It should be a fairly free 10 points. So UTF-8, this is all about content length. That said, the more you take pride in that, the happier you're going to be, as corny as that might sound. But you'll be happier if you take pride in it. And I do notice that the students who take pride in their front ends when they're doing these homeworks, like last year, and the projects too, they tend to be more motivated to work on the back end, although that might be correlation, not causation. So take that for what you will. They might just be motivated in general. But anyway, the next one, hosting images. For this, we have to do pathing. I haven't and I won't talk about pathing explicitly in the slides. I might give some examples on Friday. I haven't quite decided what exactly I want to show on Friday. It'll depend on what y'all want to see, what y'all are struggling with on this homework. But if it's pathing, I'll do pathing. So for this, instead of having a hard-coded path where you say, if the path equals /image, serve this content, now we have a path of /image and an image name, which can be any of those image names from the sample site that I gave you, any of those 8 images, image names, and you have to serve up all of those files with this path. So now instead of just saying if path is /image, here's the content. Now it's if path starts with /image/ then look for that second slash and parse this out. Grab this, treat it like a file name, open the file with that name, and then serve that content. So we have some more flexibility in our pathing at this point. That's the big part of this. Also reading binary files and sending binary images in your responses and pathing. So this is a twofer. There's two things you're working on this objective: pathing and serving binary content. And finally, what we're talking about today, we want to /images. So a path of /images, which takes a query string containing a name, which is whatever the user wants to be referred to as, and images, a collection of images all separated by this plus character that they're going to send in a query string, which is going to look like this. When somebody requests this, you have to serve an HTML page that contains a greeting that includes their name and includes all of the images that they requested. So when a user makes a request for this URL, they need to get a page that says something welcoming Mitch, because that's their name, and contains all three of these images from the sample page. That's what we want to do today, and hopefully you have some questions about that, unless you've read ahead or know what we're talking about here. So let's talk about that. And you can assume we'll talk about percent encoding for a slide today. You can assume that there's no percent encoding. We don't have to worry about decoding characters. I thought about having you do that, but it's more tedious than educational. So we can skip that. We won't mess around with percent encoding. That's all I want to talk about here. So let's head over to some slides and learn some stuff. Ooh, good question. Good question. When you serve the HTML, and this will be important for Objective 4 too, especially important in Objective 4. When you serve the HTML, does it serve the related CSS and JavaScript files automatically? Kind of. It's going to feel like that to you because the browser is going to handle that. When the browser requests your index.html, it's going to get that index.html only. So it's a request for the HTML. You serve the HTML, end of transaction. The browser is going to read that HTML document and realize, like, oh crap, this is referring to a CSS file and a JavaScript file that I don't have. So the browser is going to make two more separate HTTP requests to your server. A request for the CSS, you serve the CSS. A request for the JavaScript, you serve the JavaScript. So you're getting three separate requests that are completely independent of each other to be able to serve this page. So in your server, you'll have three separate paths, and you'll say if they're requesting HTML, serve the HTML. Else if they're requesting the CSS, serve the CSS. Else if they're requesting the JavaScript, serve the JavaScript. And then that's it from your end. And then the browser is going to make three independent requests and hit three different endpoints of your server. So same thing when we're talking about the images, and I'll talk about this again when we get to that part in the slides. But you're going to serve up HTML, which contains multiple images in it, but you don't have to serve the images with that HTML. You're going to serve HTML that contains image tags, and those image tags will have references to images, and then each time the browser reads that, it's going to make another request for that image. So if somebody in that example, Mitch, is requesting three separate images, all you're doing with that request is serving them HTML. Give them the HTML. It contains image tags, image elements in the HTML. And then the browser is going to see, oh, crap, this page needs these three images, and I don't have those three images. So it's going to make three more requests to your server, and your server handles that and renders that page in four separate HTTP requests and responses. But you handle them all independently. This is when I say, you've heard me say this before, this will start meaning a lot more to you. When I say HTTP is a stateless protocol, that's what we mean, that we're handling every request in complete isolation from each other. We don't care that we just served HTML that contains references to other requests that are going to have to be made. We don't have to think at that level. We just think, okay, my server serves HTML, my server serves images, my server serves CSS, my server serves JavaScript, all completely independently. And it's up to the browser to stitch all that together and make multiple requests to be able to get all the information that it needs. Can we request feedback on our backend code from you or the TAs? Yeah, sure. We'd be happy to get that kind of question in in office hours, to be honest. We usually don't get to talk about that kind of stuff in office hours because we're busy trying to help a student debug. That's like 90% of office hours. We'd be happy to talk about design. It'd be a nice break from the norm. If the image doesn't exist, then you get a 404 and a broken image link. And I can demo that when we get to the end of this lecture. Yeah, your site, if it's up to your server of how it handles that, but if you're following the homeworks, it should send a 404 and the image doesn't display. It requests all that concurrently. NapSeps. For performance. If you go to any modern web page these days, open up your console, there's dozens of requests made to render a single page. If it was doing that all in sequence, it would take forever to load any page. So there's a request for the HTML, it gets the HTML, and then all other requests are made in parallel as soon as the browser realizes that it has to make those requests. And then your TCP socket library is going to queue those up and then handle them one at a time, unless you have threading incorporated already, which I think most of you do because you followed the lecture examples. All right. Yeah, thanks, Ozark. I was just telling my wife that this morning. I like my hair, but she scheduled me for a haircut Sunday, so only one more lecture with this hair. But yeah, maybe don't say those things during in chat. So let's get into some things. Query strings. Let's talk about it. We've seen what they are before, very briefly, but let's talk a little bit more about the structure and the format, because for Objective-4, you got to be parsing it. You got to be parsing these query strings. So I think that's all I want to say on this slide. Oh my goodness, I lost my train of thought. At least the dog's not crying anymore. Let's celebrate that. So let's revisit the structure of a URL and talk about specifically the query string part of that, because we've already talked about the protocol, which is always HTTP for our purposes at this point, at least. We'll talk about HTTPS also, and we'll talk about WebSockets, but we actually won't. We'll start a WebSocket through an HTTP request. Is how WebSockets are initialized. So this protocol, for all intents and purposes, will always be HTTP for us. The host and port we've talked about, localhost or 0000 port, whatever port you choose, usually 8000 for the homeworks. And then the path, we've talked about that as well. You have a path for hi, hello. Those are serving different things for homework 1. For homework 2, the paths, a lot of them are up to you. Image and images are both reserved for objectives 3 and 4. But what you have for the path of the HTML, the HTML has to, did I put that in the doc? The HTML should be / the root directory. I hope I put that in there. I think I did. And the CSS and the JavaScript, it's up to you, but the easiest thing to do is to have the path for those be the actual name of the file. If you just have it as the name of the file, there's really no question of what it is, what's being requested. And then what we want to talk about today, the query string, followed by following a question mark. And then the fragment, we won't really talk about this. We won't really deal with this in this class, but it is part of the URL, so I got to mention it. I'd be doing you a disservice to not mention it. I'm distracted from the compliments. Kind of. It's just two different things that my brain's trying to focus on, like computer science, my hair. Which one do I think about? Probably not the hair right now. So the fragment is usually used for navigation. If you go to certain URLs, like if you go cut and paste a URL that automatically scrolls partway down the page, that's usually done through a fragment. So if you have the example I gave, which is actually on screen right now, a wiki page where you click on one of the navigation links, like right underneath the intro of the page, click on one of those, your URL will update with this hashtag and the fragment. And then if you send that link to somebody, it'll automatically scroll to that section of the page. And this is common in a lot of different things. You can use this to specify where you want somebody to, what part of a page you want somebody to look at. It's helpful when you're sharing links so people don't always have to scroll down to figure out what part of this giant page you're talking about. We won't deal with those. We won't talk about those. Query strings, that's what we're here to talk about today. So the query string, the format of a query string is a question mark, which is going to signify the beginning of a query string. Whenever you have a question mark anywhere in a URL, and you can't have a question mark anywhere else, and you, for example, like you can't have 2 question marks in a URL. If you have a question mark in a URL, that specifies the beginning of the query string. End of story. That's the protocol we're following, the format, the structure of a URL. Question mark is the start of a query string. So we have the path, and if you're reading the path and you find a question mark, you got yourself a query string. No question about it. That's the start of a query string. That's what the question mark character in a URL means. The query string itself is going to be a set of a map, I guess, whatever data. It's a key value store. We have a data structure of key value stores, effectively. We have keys or names. I think the documentation calls them names. I tend to just call them keys because I'm always used to just saying key value store. The keys, and then an equal sign, and then the value stored at that key. A key, equal sign, and then the value stored at that key. So this is the format that we have to parse when you're tearing apart these query strings. Since this is a key value store, the order does not matter as well. So you do have to be aware of that when you're parsing this. What I like to do is parse the query string and put the key value pairs in whatever key value data structure I have in the language that I'm using. So those of you using Python, put these things in a dictionary. These are the keys of the dictionary. These are the values of the dictionary. And then you can do more processing after that by pulling up specific keys and their values. So for the homework, you're going to have a key of images and a key of names, or name, and they can be in either order. The name can come first or the name can come second. That's not relevant. It's relevant in your parsing, but it doesn't change the data that's being communicated through that query string. The order does not matter. So we want to parse these regardless of order, and each key value pair is separated by an ampersand. So you're looking for question mark, you're looking for ampersands. To be fully robust, you should look for the hashtag as well. Again, there will be either 1 or 0 hashtags in a URL, 1 or 0 question marks in a URL. So if you have a question mark and a hashtag, everything between those 2 characters is the query string. So for full robustness, look for the hashtag as well. Then separate by ampersands, and then each value that you separated, look for the equal sign, and then you got your key value pair. The plus does not necessarily signify space. It can be used for that, and I am using it for that somewhat here. But I got like a whole slide about that plus sign. Don't you worry. So we parse this and we can get what we want. And this is a DuckDuckGo query. If you search in Google, DuckDuckGo, I believe any browser, any search engine I've tried, I guess I haven't tried very many, but at least those 2 I know use query strings for their searches. So if you type in the search box, like this is a search for images about web development, what that does is send a query string with my search in the URL directly. This isn't like a post request where we put information in the body of the request, which we'll talk about for the next homework. It's going right in the URL itself is where your search goes. And that, I believe that's why I put the plus here. I think that's what DuckDuckGo does. I believe Google does a %20 for the spaces. So that's the structure. This slide, I'm spending a while on this slide because this is the most important slide. It's the format of a query string. This is what you have to parse. And this is one of those things that we'll start doing this more often in this course. This is one of those things where I'll show you the concept in the slides, and it's up to you to write the code. So this is a bunch of string parsing, and I expect you to be able to write the code that parses these strings. I'm going to tell you the format of a query string. You got to parse the query string. Yeah, Mim, good question. I promise you we will. I think it's the next slide. Yeah. Next slide, we'll talk about spaces, %20, and plus signs. So I'll give you a really quick. It's one slide. I don't have to foreshadow it. So there's also percent encoding for this. URLs have to be ASCII only. So the header of an HTTP request or response, as we talked about on Monday, has to be ASCII only. That's the only thing it can be. So that includes the request line, the status line, and all of the HTTP headers and their values. All of that has to be ASCII only. That's the way the internet works. That's what we have to comply with. So if we want non-ASCII characters in our query string, we have to percent encode them to be able to get those characters in the ASCII string. So we're going to take our character, this character that we saw on Monday, we're going to take its hex, hex representation, its hex UTF-8 representation. So this in UTF-8 is the bytes ED959C. So we do a %, 1 byte, %, 1 byte, %, 1 byte. This is a 3-byte character. So we have 3% encoded bytes written in hex in the URL itself. And I can't cut and paste it. And I'll give a demo of that. Hopefully I don't forget to do that. I want to do that one. You can try this yourself. If you do a Google search for a non-ASCII character, look at the URL, and it's going to be % encoded because we can't send that UTF-8 character in part of the query string because the query string is part of the path, and the path is part of the request line of an HTTP request. That's part of the header of the HTTP request. Has to be ASCII only. ASCII only, that's it. It says hand. Do I have a typo? No, I don't see it. I don't see where it says hand. Or is that what the symbol means? Oh, hand. That's what the symbol means. Oh, cool. And a single space, this is one that you'll see often, is %20. That's its ASCII encoded value. There are certain characters in URLs that are reserved. For example, the question mark, you can't have a question mark. So what if you want an actual question mark in your query string? You're going to have to % encode it and % encode its ASCII value or its UTF-8 value, which would be the same value. So a space is a %20. A space is not allowed in URLs because that's going to break your parsers. You're looking for spaces to parse the request type, the path, and the HTTP version. If you have a space in your URL, that's going to break your parsers. It's going to break everybody's parsers because we're looking for spaces. That's what the protocol says. So we can't have a space in the middle of our query string. That's not allowed. %20 to encode that. So in a lot of URLs, you'll see that %20 to encode a space. That's going to be the space character in the UTF-8 string. We can also use plus signs for this. This is interpreted a little bit differently. Plus sign indicates that you're sending multiple values in that query string. So in our objective 4, we're sending multiple values as multiple images. And we separate them by the plus sign to say, hey, these are multiple values. And then when you're parsing that query string, you can separate on pluses to get all the independent values. To get all the images that are being requested, separate by plus sign and grab each image name and then pull up that, put that image file name in the HTML. So sometimes, as we just saw with DuckDuckGo, the plus sign is used to separate multiple words in a query, which we commonly use a space for, or we can use %20 for that. We see different behavior. I believe Google does %20 and DuckDuckGo does a plus sign to encode their spaces. But plus sign in general is part of the protocol and is used to separate multiple values, which puts plus sign on that reserved character list. You can't have a plus sign in a path. You can't have a path that contains a plus sign unless you percent encode it. So any of these reserved characters, which are used for other purposes in our URLs, we can't use them for anything else. We're looking for ampersands to separate key value pairs in the query string, so we can't have an ampersand anywhere in our URL unless we percent encode it. And like I said, on the homework, we're not going to have to worry about percent encoding. We're not going to test with those strings. We're not going to mess around with that. I'm not going to make you look for these percent signs and do that. So for what it's worth, you ain't gotta, you won't have to parse these. But when you're looking at query strings and when you see them out in the wild, you're going to see this percent encoding quite a bit. Would %20 work in both? No. Yes and no. They're doing the same thing, but like if you go to DuckDuckGo and you go to the URL and replace their plus signs with %20, it's probably not going to work because their backend is coded to look for plus signs. But they could just recode everything. They could switch to %20. Google could switch to plus signs. But the front end and the back end have to be speaking the same way. They got to be talking the same language. Yeah, so it's like an and. I want kittens and dogs and... Yep, exactly, Mim. And let me sneak in a demo right here. Since query strings are fresh in our mind. So let's make a DuckDuckGo request. If I click up here, I can see the query string. Let me use this just because I have it open. Mike lecture isn't over. And we can see the query string. DuckDuckGo start the query string. This is a query for software plus engineering. So they're separating those values with that plus sign to say that these are multiple values. Let's try it actually. Let's %20 this. It knows that I'm using Opera, and it makes a web search, not as opposed to like an image search. So that's the query string that DuckDuckGo is going to read, and I can actually change this. All this box does is creates your URL that you're requesting. So if I do, if I want to make a search for chemical engineering, let's see if that I shouldn't do the %20 and this, just in case it breaks. And I can use my URL directly to make that request. Yeah, I handled the %20 just fine. So that's good. I believe there's a space there. Yeah. So we can make a different request. I can change this. Oops. I can change this to an image search. It should give me images. I think I got the wrong. IAX equals images. So I hit the wrong thing. But you can manually do that in the URL. A Google search. They also want to know what browser I'm using. It's interesting. Oh, they are using plus signs. I swear they used to use %20. It's my story. I'm sticking to it. It's interesting. Yeah, they changed %20 to plus. Yeah, interesting. They messed up my example, but for whatever it's worth. Will you do images equals cat dog or images equals cat without the .jpg? That says it in the requirements. Without the .jpg, so you have to add that file extension in there. All right, let's talk about HTML templates. So we have this problem. The next problem that you're going to face. We're parsing query strings. Great. Cool. The next problem you're going to face is that you have to serve up custom content based on the values in this query string. So we want to send, I think quotes have a different meaning in URLs, but I don't remember off the top of my head what they mean. But they do have a special meaning. So we have to serve up custom content based on this query string, and we have 8 different images that can be requested, which is going to give us 256 unique combinations of images that can be requested. So how are we going to do this? Are we going to store 256 unique HTML files and then based on the query string serve up a specific file? We could do that, that can work. But the user is also sending their name in this query string. So for each possible name that can exist, we're going to have to store 256 HTML files for each name, which is going to be millions of HTML files, and that's still missing basically every name. Like you're not going to be able to cover every possible name that somebody can have, especially when people start using their usernames. They can just make up whatever they want. We're not going to store a set of 256 HTML files for every single possible name that can come across, that can come to us in a request. It's simply not feasible. You're going to run out of disk storage among many, many other problems. This is just horrible. How are you going to maintain that? It's just not what we're going to do. So what we're going to do instead is HTML templates. That HTML templates to the rescue here. So instead of writing our complete HTML files and having these files and then opening the file and then just serving it, sending the bytes of that file over the internet, instead, what we're going to do is create incomplete HTML files or HTML templates and then use those to generate the HTML that we want when the request comes in. We'll get the request, we'll take our template, and we're going to combine our HTML template, which is the structure of the page, and combine it with the request that contains the data of that page. So we combine data with the template, create our HTML, our complete HTML, and then send that across the internet. And we can start seeing how we like to have everything separated. HTML templates are the structure. We used to have HTML hard-coded pages, and I would say HTML is the structure and the content. Well, now we're separating that again, and then we'd have like CSS is the style and JavaScript is the functionality. Well, now we're separating HTML and getting that structure and content away from each other and having templates just be the structure and then the content being added dynamically upon each request. So let's see how this can be done. And this is largely up to you how you want to do your HTML templates. You're welcome to look at HTML if you're looking for a keyword to search for, HTML template engines, and you can look for some of the syntax that they use, but you'll be writing your own HTML templates. In the spirit of the course, template engines are banned for the homework, but allowed for the project. So what we do for an HTML template is write all the structure of the page and then have placeholders for the data that can be served dynamically. Any data that can change based on the specific request, we're just going to put placeholders there. And I like this notation. This notation's from Handlebars, which is the template engine I've kind of gravitated towards. I've started to use that one. This double brace. This is the important thing about what you use for your placeholders in your templates is it shouldn't be anything that ever appears in your HTML itself. So it's not going to be confused with any HTML. And double braces fits that pretty well. It'd be pretty rare that you'll actually want something surrounded by double braces in your HTML, in your actual page, actual content. If you do want that for some reason, maybe you'll want to use something else to indicate a placeholder. But whatever you use, you want to have some way of indicating that this is a placeholder that will be replaced with the actual data later. So here I have an HTML template with 3 placeholders, a title, which is going to be a big thing at the top of the screen in header 1, a description, and an image file name. So when a user makes a request and gives me these 3 pieces of information or wherever I'm getting this data from, I'm going to open this file. I'm going to look for my placeholders and replace them with the content of that for that specific request, for that specific response that I'm constructing. And then once that's all settled and I have my data combined with my template, then I ship that over the TCP socket and send that to my user. And you can use a simple find and replace. For our purposes in this class, that'll be fine. Find your placeholders, actually, except in the next slide. But find your placeholder and then replace it with the data that you want to be stored there. That gets a little trickier when we're doing loops. For your Objective-4, you'll have to have a loop in there somewhere where you're taking a list of image names that can be anywhere from 0 to 8 images long. Actually, we won't test with 0, I suppose. So 1 to 8 images long. So you don't even know the length of that. So you can't have just straight up placeholders, image 1, image 2, image 3, image 4. What we'll want is a loop where you're somehow denoting that, hey, this is a loop where we can add this code, this HTML multiple times depending on some data structure. I have some data structure of data, and I want to render this HTML for each element in that data structure. So I'm going to loop over and write this string with this replaced with the data from my data structure for each value in that data structure. If any of the images do not exist, should we return 404? We won't test with invalid images. You should assume that they're correct. And if any of the images don't exist, that image request will get the 404. So the images that are correct should still render, and whatever image name doesn't exist, that one should have the 404. Can you repeat that? The loop part? So if we have a data structure, like you're going to have a data structure of image names that you want to render on your page, you'll have to have some way, and it's up to you how you want to denote this in your template, but you have some way in your HTML template to say, here's where all the images go, and for each image, this is the HTML that should be rendered for that image. So you get your first image, and that name is cat.jpg. You'll have some code here, which will be at a bare minimum an image tag. You'll have an image tag with an href equal to some placeholder, which is going to be the path for that image name. So you're going to loop over this string, and for each time you iterate over it, you're going to add to your HTML whatever code is here. I called it code again. You have to forgive me for that. Whatever HTML is here with the placeholder replaced. So if you have a placeholder as your not href source for your image, you'll have to replace that placeholder for each image that you're rendering, and then have all of that HTML in your final HTML that you're sending for each image. So here, if I have a data structure that says with the strings, I'm just going to steal your comment about the loop. So I would iterate over this. I would think of this as a loop, but I'm doing this all, by reading the text and looking for these tags. But I would have H6, my final HTML would have to be H6 hello, H6 about, close H6, H6 the, close H6, H6 loop, close H6. That'll be my final HTML. And then what I'll have is very big letters, or actually H6, very, slightly larger than normal letters, about, and then on a new line, the, and then on a new line loop, because H6 will include a new line. It's all about string manipulation. Objective-4 is all about tons of string manipulation. Exactly right, Jory. Parsing the query string, opening this file, parsing all this text, looking for your placeholders, and then having your special tags have some way to denote the beginning and end of your loop. Have those that you're going to look for and read everything in between those two tags, if you're using two tags, depending on how you do it. And then replacing that content, yeah, it's all ton of string manipulation. You will be doing a lot of string manipulation for Objective 4 specifically. Lots of string manipulation. And yeah, use string manipulation. Yep, string manipulation. That's what this is all about. Yeah, there's just going to be a lot of that. It's what a lot of web stuff is, at least at this level. Do we keep the loop stuff after? No, that the loop stuff would go away. This wouldn't show up in your final HTML. You don't want your end users seeing that. Any of your templating placeholders. So all that would go away, and you would just have body H6 content, H6 content, H6 content, and body end HTML. That's what the user's going to see. So that's, by the time you ship it over the TCP socket, all of these placeholders are gone. This is just a way for you to be generating dynamic HTML content without having to just serving HTML files. So however you can get the job done for your homework, that's up to you. Templating engines and this syntax specifically for handlebars and a few other templating engines is how it's done out there in the real world. This is the type of syntax you're going to be using out there for your project and when you get out there in the world. If you use a different engine, the syntax will be different, but you'll see something like this. So to get the most practice, I would use this syntax and write your own templating engine to parse those templates. Which engine are you using? I like to use handlebars personally. This syntax comes from handlebars, this double brace syntax. But for the homework, you wouldn't use any engine. But for my, non 312 homework stuff, I like handlebars. I've gravitated towards that for whatever reason. There's so many template engines. Most of them I haven't even looked at. Handlebars does what I want it to do. I don't see a need to change or shop around. And you can have conditionals. This is a common thing. You won't need conditionals for this homework, but this is, anything you can dream up, you can throw in your template engine and then parse that. As long as you're writing code to parse, looking for placeholders in the same format. So if you say, I want my if statements to look like this, then in your code, when you're rendering a template, you look for if statements that look exactly like that, find a value for cookie set, and check if it's true or false. As long as that's what you're doing, that's going to be fine. It's up to you how to do your templating syntax. But feel free to just steal this from handlebars and use that syntax. So, homework 2 recap again. You're going to need a page that displays the user's name and all their requested images. Now, each image is going to go in the source property of an image tag. So like you have a loop, and then you have an image, source equals placeholder for the image name. That's all you have to do in your HTML template is add those source tags. Just like you would if you hard-coded the HTML, you're gonna have an image tag, an image element with a source property with the path of the image that should be requested. That's all you have to do for the HTML. The browser's going to get that, and just like it would if you hard-coded it, it's going to make additional requests for the images at those paths that you specified. So you serve your HTML after the template. The browser reads those sources for the images, and then makes separate HTTP requests, which are going to hit your paths from Objective 3. So your paths in those src tags should be image/kitten.jpg. It should be in that format. And then the browser is going to make those requests for those images, and you're going to be able to get all those images rendered on the screen. So if you have 3 images, you're serving your HTML template and then getting 3 more HTTP requests, which hits your paths from Objective 3 to actually get the images themselves. No handlebars. And I talked about that quite a bit. All right, let's get to... I say examples plural, but I think I'm only going to have one. All right, so there's a lot of, so this is, where do I want to start? This is a server from scratch that I've written using Scala, so the language won't help any of you unless you decide to switch to Scala. But I want to highlight the concepts here, and I don't want to give away homework solutions and homework code. Before I start scrolling through this and start explaining some things, I have this util and request, these util and request classes and objects. This is code that I've written, so sometimes you'll see things like this render template and util.sendTextResponse. These are methods that I've written. I'm not using a library here. And I recommend that you do similar things. Split your server code into multiple files and start using encapsulation and OOP or FP, whatever structural, architectural approaches you want to use. Start separating your server into smaller pieces. And I should have had Kobe as one of the images. And then I'm calling my method. So sendTextResponse is my method that I wrote that's going to take these parameters, take these arguments, and send a text response to the user, to this this sender, this reference to the client. So don't panic. Don't be like, hey, he's cheating on his own homeworks. No, I wrote util. Everything in util, that's my stuff. But I do that. I will actually go into util in this example. But I do that to hide solutions, so I'm not just giving you code. I'm going to go into util because a lot of stuff that's in there you already did for homework 1. So I'm getting a GET request. For this is the path I want to talk about for /discord. And I want to send certain information using that template that we saw. Using that template that we saw in basic template in the slides. This is the same exact thing that we saw in the slides. So I have these 3 placeholders, and I want to replace them with some actual content to go along with this structure. So when I get a request for Discord, I want to replace those placeholders with information about Discord. So the title, I'm going to say title, and this is just a key value store in Scala. Title is going to map to Discord. Description is going to map to this description, inviting people to the Discord. And image file name, I'm going to do discord.png, which I have another path down here. I recommend this as well. Another path that takes care of all of my static files. Whenever there's a request for something that doesn't match any of my paths, if it gets to this part, I'm going to check. I'm going to treat that as a file request. So if this is style.css, it's not going to match any of my other paths, and actually redirect should be above this. It's not going to match any of my other paths. It's going to hit this one and say, well, this must be a request for one of my static files. And then I'm going to send that static file, look up the MIME type for it, and then send that static file. So I have discord.png and image.png as the MIME type. And this path is going to handle that actual serving the image. Now to render the template, I have the HTML, the structure, I have the data. To put that together, and this is where I'm actually building my responses, is in this util. To render that template, I'm going to read the template. That gives me the entire file. This is going to give me the entire file as a string. This is HTML, so I can read it as a string. An image, I would not read it as a string, of course, like we talked about last time. And then I'm going to iterate through all of my key value pairs. I'm going to look for that placeholder and just do a simple find and replace here. I'm going to replace that placeholder, all instances of it for what it's worth, with that value. So of course this will be more complicated when you're doing your loop, but this is how you can do it for replacing the placeholders with their actual values. And then let's spin this thing up. Done with these. And oops. I went to the wrong path. And this is how our template renders in the browser. So we have our placeholders replaced with the values that we have. We can see that we got this dynamic HTML. Like this as a file, as an HTML file, does not exist on my server at all. I just have a template which has this HTML with placeholders, and then I replace those placeholders with the data that I want for this specific request. And then we can see the network, we get the HTML, we get that template with all the data incorporated. The browser sees, oh, you have an image here with some source. I don't have that image. So what the browser does is makes another request for the image, gets my response for the image separately from the HTML, and then renders that on the page. The browser is going to make two requests to make this page happen, one for the HTML and one for the image. So when you're building your template, you don't have to think about how to read the image files and how to do any of that. Just put your path, which for the homework should be images. For the homework, this is going to be image, not images, /kitten.jpg, something like that. So you have to have a template that loops over all those images and gets your image tags like this for each image that's being requested.